Welcome, ladies and gentlemen. So you've gone out and you've purchased your 3D printer. You got it all set up at home. You've downloaded a couple things from Thingiverse, but now you want to actually make your own three-dimensional models. So what I'm going to do is I'm going to show you how to do that easily. What you'll want to do is you want to go and download Blender. You can simply just Google Blender, look for this little icon, download whatever version you want. I'm going to use Blender 2.75. It hasn't really changed much in the last 5-6 years. I'm sure there's going to be a new version, but it won't be much different than this, so let's go from here. First thing you're going to do is when you open up Blender, you're going to get this. You just simply click and it disappears, and you're going to start off with your standard 2x2x2 cube. Now, this setup alone isn't going to be enough. What you're going to need to do is press the letter N on the keyboard, and that's going to bring up this panel. And this is your location and dimensions panel. It'll actually allow you to be very specific as you're designing your whatever you're designing. For this tutorial, I'm actually going to make a micro drone frame. So I'm actually going to show you kind of how I built the one I have. So to do that, the great thing about Blender is you can actually create an object and then use another object to cut out other objects. So for example, this is a micro drone, so it's going to have 4 8.5 millimeter wide or diameter motors that are 20 millimeters tall. So what I'm going to do is, instead of trying to create a cylinder to encase that, I'm going to actually create the model to actually allow to use that. So first thing we're going to do is I'm going to get rid of this cube because we don't need a cube at the moment. So if you press delete, you can click confirm. I'm going to go over here to the left, I'm going to click create. And I'm going to create a cylinder. So now we know the dimensions of our cylinder are going to have to match our motor. So we know it's 8.5 by 8.5 by 20 tall. Now, this program measures everything in what they call BUs, or Blender units. Not a big deal when you're dealing with most slicers. I mean, this will actually equal 1 unit will equal 1 millimeter inside of the actual slicer. So I'm going to set it to 8.5 by 20. Now, you're going to have to remember, though, 3D printers aren't exact. There's going to be overlay all the way around. So when it tries to print a cylinder, it'll actually print slightly smaller than a cylinder as it extrudes more into that cavity. So I want to add a little bit of clearance. So what I'm actually going to do is I'm going to set this for 8.7 by 8.7. It's not much. It's 1/10 of a millimeter, but it'll make it easier for the motor to actually fit inside of the frame when we're done. I'm going to leave the height pretty close. Now, actually, I am going to modify the height just a little bit. And what I'm going to do is I'm going to drop it down, let's say 1 millimeter. So I'm going to go to 19. Now, the reason for this is the motors are actually tapered on the top. I want this motor to actually sit inside of its connector. So what I'm going to do is I've dropped it down, so I've taken 1 millimeter off, but I'm going to add that millimeter back to it. So to edit this cylinder, I'm going to press the tab on the keyboard, and it's going to go into this edit mode. Now, you have your 3 basic edit orientations, I guess. One is you're going to have your vertices. Your second one is your edge selection. So if you can select edges, allow you to modify edges, and the last one is your face selection. So for what we're going to do right now is I'm going to use face selection. I'm going to select the top of my cylinder, and I'm going to press the letter E, and that's going to actually extrude. So I've pressed it, it's extruded the surface, but it hasn't set a height yet. Now this point is very easy. All I'm going to do is I'm going to use the number pad, and I'm going to press 1. So basically what's happened is it's extruded 1 Blender unit, which will equal 1 millimeter. If I press 1 again, well, that's 11 millimeters. So, and you can press back. Now, you'll notice that there's no actual reference point on the screen to what I'm pressing. There actually is. If you go into the bottom left-hand corner, you'll see D. Right. Oh, I'm in the middle of doing an edit. So I'm going to go back to just my 1. Press Enter to confirm. But, see, that kind of messes things up. I'm going to press Control-Z, which will undo. So I'm going to extrude once again, and then yeah, just look in the bottom left corner, you'll see I pressed 1, 1 again, 2, 3, so I've actually right now extruded 1,123, way too much, so we're going to go back. So now our cylinder is back to 20 millimeters tall. But the reason I've done this is I want to actually bevel the top of the motor. Easy way to do that now is, now that I have extruded a surface that's only going to affect 1 millimeter of the motor, I'm going to actually press the S key on the keyboard. Now you're going to want to remember all of these little keys. N will bring up that side menu, E will allow you to extrude, and S will allow you to scale. So I want to scale. Now, because this is only one-dimensional surface that I've actually attached, when I scale this, let's say I want to go 0, remember in the bottom left corner, 0.9, it'll actually shrink it down to 90% of its scale, but it'll only do so on X and Y, and that's because I've only selected 2 dimensions. The other way, though, let's say you selected a 3-dimensional surface, so you're selecting basically a whole object, and you want to shrink and expand it, what you would do is you would actually press Shift Z, and what that'll do is that'll remove Z from the equation, and now it's going to scale on X and Y. If I was to just press Z on its own, it scales on Z. If I press X, it scales on X. If I press Y, it scales on Y. So what we want to do, though, is we want to scale on X and Y, and because when I press X it goes to X and Y, you go to Y, you press Shift Z, which just negatives Z out of the equation, and you end up with this. So now if I press Tab again, it'll exit me out. I now have an object that, if you look, is 20 millimeters tall, 8.7, 8.7 for diameter. If you press the center mouse button, which is often your wheel, you can use the wheel to scroll in and out, and if you hold it, you can actually rotate the object. Very easy to do. If you want to, let's say, move an object, press the Shift key, and still using that wheel, you can move it around. Pretty simple. If you want to, let's say you have it off to the side and you want to center in on the object, if you press the period down by the bottom right corner of your number pad between your enter and your 0, it'll actually center right on an object. Very easy to do. Okay, so now I have the basic shape of my motor, plus a little bit extra to allow for tolerance. So now what I want to do is I want to just symbolically add a shaft for the actual propeller. So to do that, I'm going to take one of my motors, and I keep just this excuse me, little measuring tape on my desk, and it is right here. Okay, so I have a shaft, and I want to measure that. So it looks like it looks about 4 millimeters. So I want to create another cylinder. And remember, you want to be out of tab, because if you create it inside of here, it's just going to automatically add it to the object. It's going to be a pain to work with. So we're going to create a new cylinder. And if I press, it's disappeared on me, and that's just basically because my old object's in the way. I press the period to allow me to zoom in on it. But so what I actually want to do is I want to move this object. So I'm going to select this object, and you'll notice that its location is 0, 0, 0. Okay, so that's dead center. So I want to actually increase the Z to, let's say, 20. That'll get it nice and high. Okay, now I can manually use the arrows to drag the object in any axis. Or, if you right-click on the object, you can basically free move it any way you want. But now I've moved it out of center. Oops. And then you have to, click again to release it. So I want to move it back to 0, 0, and let's go 15. Okay. Now we want to set this for, let's say, the shaft. Remember, this is mostly just for clearance issues, so I'm going to go 1 by 1. So this is 1 millimeter shaft, and because I measured, let's say, 4, I'm going to go to 5. So now I'm going to just intersect the two of these together, right-click on the object that I want to be the principal, and I'm going to go over here to this gear. Click on the gear. Now I'm going to select Boolean. Now what Boolean will allow you to do is basically modify one object with another object. So, well, of course, first thing I'm going to do is I want to actually union these two objects. So I'm going to say Boolean union, and then I'm going to use the little teardropper or whatever to actually select the object. The other thing you can always do is, if you know the name of the object, here it's cylinder 001, I want to Boolean, and we'll type we can either select it from the list or start typing the actual object and select it there. Alright, so apply. Okay, now the original object is still going to be there. It was just used to actually create the mold. Now, I'm going to measure out my propeller because, once again, this is all about clearance. So, I've measured the propeller. The propeller is 55 millimeters. So I'm going to change the diameter of this to 55 by 55. And now what we want to do is we want to measure the actual height, like the actual space that the propeller is going to consume while it rotates. So actually 5 millimeters looks like it's going to be good clearance. And it looks like it's going to sit probably about 1 millimeter off. So I'm just going to kind of drag this up. Now, actually, in fact, what I want to do is here. If we select the object, now if you want to get a wire mesh, you can always press the letter Z on its own, and that'll actually give you a wire mesh view. So I'm going to press Tab, and I want to get the direct height of the actual motor itself, because I want to actually make the blade 1 millimeter clearance above that. So one thing you're going to want to be sure of is you have local and global variables here. We want to actually go to the global. And this will actually give where its position is on the screen versus its position to center. So we're going to go position to screen, and we have 10.5. So what we're going to want to do is to make this object exact with that object. This is going to be, you're going to want to find center of this, because right now its center point is direct center of its mass. So 10.5 plus 2.5 is 13. So if I go to 13, those two objects should meet up perfectly. Now I want to add 1 millimeter space, so I'm going to go to 14. Done. So now I have a motor with a shaft and a propeller. And what I'm going to do is I'm going to go back to the Boolean tool, and I'm going to union the propeller. Done. Apply. Now I have this whole unit as a direct cutout. So that's pretty good. So next step is I want to actually position these motors to where they're going to belong. So I mean, you could do this. Let's say you want to do a 90, a 110. You can measure it out that way. What I like to do is just easy as possible, little thinking, little math. I'm going to press Control C to copy it, just like you would text, and Control V. I've now created a copy. So I'm going to position, let's start off by going 30 to the X and 30 to the Y. The next one, I'm going to go negative 30 to the X, because we're going to try and stay proportional to 0. This will make the object a lot easier to produce. So we're going to go negative 30, and once again, positive 30 to the Y. So that looks pretty good. I mean, very little space in between those two. Now, with my model, I did ducts. So I'm actually going to show you ducts on this one as well. And when I do ducts, I do proportional to 34. So we're going to do negative 34 by 34, 34, 34. So these are positive and negative on the positive X. So I'm going to copy and paste this one. And I'm going to go negative 34 on the Y. Control C, Control V, and negative 34. Okay, so now I have 4 motors. Pretty easy. So next step is we're going to want to do, let's start with the actual duct itself. So we want to do a duct that's going to have enough internal clearance for the motor, for the propeller. And we know the propellers are 55, but we're going to want to leave a little bit of tolerance. So let's create a new cylinder. I'm going to leave the cylinder at 0, but I'm going to elevate it to give it better visibility. I'm going to press the period to center myself on, and then now what I'm going to do is I'm going to give it size. So those were 55. If I go to 56, that's half a millimeter on each side. If I go to 57, that's a full millimeter on each side. When you're doing ducts, you want to be very close with your propeller edges. If not, you lose the actual efficiency that the ducts are supposed to give you. So what I'm going to do is I'm going to do 1 millimeter clearance all the way around, which is 2 millimeters over the whole diameter. So I'm going to do this as 57 by 57. Okay, so now what I made this for was to actually use as the cutter. So I'm going to set this to 10 tall, and I'm going to Control C, Control V, copy it again. I'm going to select the copy. Remember, right-click will allow you to select. And I'm going to give it a new size. Now, this is a micro, so I don't want it to be too heavy, but I want it to be sturdy. So let's say 2 layers thick, for example, because this is going to be a pretty small frame, and I want it to print 2 layers. I know for me about 0.6 millimeters is the terminal between my old layer and a new layer on my printer. You're going to need to take a few prints to actually figure out, what your sizes are between your printer doing it in 1 layer or doing it in 2 layers. 2-layer thick walls are a lot stronger than a single layer wall that's extruded thickly among what the 2 layers would normally handle. And that just has to do with multiple adhesion points for, especially when you're printing with high heat. So 5757 is my cutaway. I'm going to want to create the actual, so I'm going to do this as, let's say 1 millimeter for the, let's do 1.2. So if I want it to be 1.2 thick, I'm going to need to add 2.4. So let's do 59.4 as my diameter. I like to cheat a lot of copy and paste. Now, I want to make sure I get a clean cut, so I'm going to reduce the height of this to 5. I'm now going to, with this object selected, so I'm going to, first of all, just because sometimes it'll be hard to actually select other objects, cylinder 5 is the cut object. So I'm going to select the other object, I'm going to go back to my Boolean tool, and I'm going to go to Difference. And I'm going to select cylinder 5. Now once I apply, I can actually delete that cylinder. I now have a duct that should be 1 millimeter clearance and 1.2 millimeters thick all the way around. So now I'm going to put this back to 3434 and just pull that down over top and just visually check to make sure that, my math is accurate. And it looks like it's going to be pretty good clearance. Next step you're going to want to set is your actual height. So let's say I want to do these ducts at 7 millimeters tall. Done. So now with straight ducts on their own, they're actually not very strong. They'll flex a lot more and they'll have nothing that's really going to produce a resistive point. Also, when you look at ducts, they're not straight up and down. They usually have like a curve or an edge on the top. So to do that, I'm going to isolate this object on its own. And to do that, use the slash that's up by the number key. And that's going to take you into a space that just has that object. I'm going to press Tab to highlight the object. I want to be in face mode, and I'm going to select the 2 faces. So right now the whole object is 7 millimeters tall, and what I'm aiming for is 1 centimeter in total. So I'm going to add a 3 millimeter, I'm not sure what to call it, but you'll see as I'm creating it. So I'm going to press the E to extrude, and then I'm going to press 3 for 3 units. So now that's actually produced another segment on top of it. And then I'm going to press Scale, and I'm going to go to 1.1. Okay, that's too much. So 1.05. That looks pretty good. So remember, I only selected this 2-dimensionally. If I wanted to scale this as, let's say, all of it, and if you press the A key, it allows you to deselect or select all. So now if I was to press, let's say, scale 5, the whole, that's probably a bad example. Let's do scale 2. Not only is it scaling on X and Y, it's also scaling on Z. If I press Shift Z and I press 2, now it's only scaling on X and Y. And if I press Z on its own and press 2, you'll notice that now it's only scaling on X. I mean, you can do this with anything. Shift X will allow you to scale on basically X and Z at the same time, which will distort the object. I'm in edit mode at the moment. And then if you press, let's say you're in the middle of doing like a scale or something like that and you want to cancel, pressing escape will restore the original object. But this is basically what I want. So now, because I scaled the upper edge anyway, it's actually going to make it a little bit thicker because it just does. It scales it out. So I'm going to go back to Tab, but what I'm going to do is I'm going to select Vertice, and I'm going to make my way around the outer edge. And to do that, you can either hold Shift and select each point on its own, or if you hold the control key and right click on a point, it'll actually take the shortest path. So you don't want to go from one end to the other, or it's going to cut on the inside and go around. But if I go smaller segments like this, it's going to actually just follow it around. I made it all the way around. So I'm going to press the period again to center in on it. I'm going to press 7 on the number pad because I'm not in any feature. And it's going to give me an overhead view. If you press 9, it just flips the view. If you press 1, it gives you a side. 3 gives you a front. 5 gives you the kind of square-on view. You can press 5 again to turn that off. 4 allows you to rotate left. 3 or 6 the other way. 8 and 2. So I'm going to press once again 7. Now what I want to do is I want to actually thin up just the upper edge. It doesn't need to be so thick. So I'm going to press scale, and I'm going to go 0.99. Or, okay, 98. That looks pretty good. So you'll notice that I'm eyeballing a lot of this. And I mean, at the end of the day, it really doesn't matter. You can do your math and figure that out. To figure this out itself, you would actually take what your current width is. So because this is right now at 34 by 34, if we center this, so the object's now centered, and I select my outer point, you'll notice that it's 30.56. Let's say, and this is 29.92. You can actually do your math, 100 divided by what you want, times whatever, and I do it all the time when I need to. When I don't need to, you can eyeball a lot of this stuff. So that's pretty much it. That's our duct. Very simple, 1.2 millimeters thick, and it has a nice curve on it. But we want to reduce a little bit of weight, and honestly, the duct doesn't have to be completely all the way around. So let's head back to the actual. So I'm going to press the slash. I'm going to go back to 34. 34. So there we go. That's our duct. You'll notice that gives plenty of clearance to the motor. But we're going to need it to actually come down over the motor a bit. So I say that's probably a good height. Let's go 10. Oops. Say 10 as our height. That should protect the propeller and the motor pretty well. Okay, so let's expand those ducts all the way around. Control C, Control V. Same as before. Control C, Control V. Control C, Control V. Okay, so if I select my motors and propellers and press the H key, which hides them, you'll see I now have 4 ducts. So now that our ducts are in a row, I'm going to press Control Z, which just undoes the last thing, which was hide, so that brings them back. So now we're going to want to actually make it so that we can mount the motors. So the motors are at, we already know they're 8.7. So what I'm going to do is I'm going to actually select one of the motors, and I want to do the positive 34 by 34, which is this motor. I'm going to isolate it into its own frame, and I'm going to create a cylinder. So the cylinder I created is on 34 by 34. I'm going to move that to 0. Good. I'm going to move the motor to 0. Okay. So let's say this is 8.7 by 8.7. Let's go. Let's do a 1 millimeter thick. So 8.7, 8.7, 9.7, 10.7. 10.7 by 10.7. And let's go 6 tall. Nah, let's go a bit more. Let's go 7 tall. Okay, so we slide this right on up our motor. In fact, actually, you know what? We can just, for ease, I'm going to slide it straight on up into the top of the other one. It's going to give us a clean cut. The measurements are going to be good. So I'm going to go over. I'm going to select Boolean difference. Done. apply. Let's go back, center, select the object, isolate the object, and now when we look at the object, we have a closed-in motor face. Okay, so that's one way. Now, with it being closed in, I mean, you actually, the motors will get hotter. They don't have those little tiny holes to actually let out any air or any heat that's kind of building up in there. So, I mean, this way allows you to prevent dust, and like for me, I fly in the shop a lot, so I may want to actually close off the top of the motor or add my own vents. You don't normally need to do that. So what I'm going to actually do is I'm going to create another cylinder. 0, 0 is good. Drag it up. I'm going to go, let's go 15 tall. That gives us plenty of clearance. It's kind of whatever. I'm going to press 7 to get an overhead view. Press Z. So that's our inner edge. So I'm just going to estimate at this. Let's go 6 by 6. You'll see that I'm still not quite hitting that inner edge. Let's go 7 by 7. Eight by 8. We've gone too far. 7.5, 7.5. That looks good. It's just on the inside of the edge. Z to get out of there. Boolean difference. Select, apply, and let's get rid of the cutter. So here we go. Now that's a bit too much material, so I'm going to go back over, select. I'm just going to shrink that down. Eyeball that. Actually, do you know what? Let's do this right. I got to teach you guys how to do it right. So this is 10.5 is what our upper angle is. Let's say we want 0.5 millimeter on the upper face, so 10. Oops, escape. 10.5, we'll go 11. So that should be 0.5 all the way above. Perfect, so that's 0.5 millimeter thick. Back out. So we're going to place that at 34 by 34. Put this guy at 34 by 34. You can zoom on in. Let's just inspect that. So we got our clearance. We got 0.5 millimeter clearance. That looks pretty good. Okay, so select just that object, Control C, Control V, negative 34, Control C, Control V, negative 34, and Control C, Control V, negative 34. Alright, so our heights are good because I didn't move them along the Z axis, so that's where we want our heights. So not too bad. Okay, so now we need to add a bit more strength here. So we want to actually join these motors and everything together. So to do that, I'm going to create a cube. Now, 34 on the Y will line us up dead center and then 0. So our next step is I'm going to press period to zoom in on it, set my height, and we're going to need to join everything. So next step, let's do some guessing. So I'm on the y-axis. So y-axis is your forward and back. I'm going to want my length here. Let's go, well, we know 34 and 34 to center. So, oops. Let's go 34, 34, 60 plus minus 4 point, okay, let's just do 60. Okay, so 60 came pretty close. So I'm going to give this object a name. So I'm going to call this motor 1. And I'm going to press H to hide it. Motor 2, H to hide it. Motor 3. You'll notice I'm moving my mouse back over the window. That's because if I press H over here, it's it's going to remove whatever I've selected. If I hold it over here, it's going to move whatever object is selected in this window. H will hide it. Select this, and this is motor 4. And hide it. Okay, so now we have this. So we want to make sure, first of all, that we're not protruding into the other object, and we are. So 60 was just too far. So let's go 59.5, still too far. 59, there we go. You'll see that the object is no longer protruding into the other object. And the same goes for there. Thickness. Now this is going to be the main supporting arm for everything. So we're going to print this in ABS. So let's do our thickness. Once again, I want to be about 2 layers thick, maybe plus a little more. So let's do 1.4. There we go. And then our height. Now I'm actually going to cheat and show you how to kind of clean all this up, because you're going to be printing from a 3D bed. So that bed is going to need to be, you're going to need to make sure the object is absolutely flat on the bottom. And instead of doing the math, I'm going to show you how to kind of overshoot everything and then just do a quick cut to line everything up onto a single surface. So let's go 6 tall, and I'm going to drop that down to, I say that's probably a good height right there. That's a good joint. Good joint. That'll give us about, okay. So Control C, Control V, and I'm going to put, what the heck is going on here? Oh, our center's moved. It used to be at 34. Oops, I must have dragged it somehow. 34, 34. Okay, this one I'm going to do at negative 34. I'm going to copy it, paste it. I'm going to move it to 0 on the X and 34 on the Y. And I mean, I could change the dimensions down here, but you need to learn this anyway. I'm going to press 90 on the Z to rotate it on the Z. Copy it, paste it, and negative 34. Okay, so now we have the base frame. Now, because I want to keep 0 as my center, what I'm going to do is I'm going to create a cube. I'm going to put that cube as 0, 0, 0, 0. Done. Okay. So I'm going to hold down the Shift key, and I'm going to select each object. Actually, no. I'm going to go, first I'm going to hold the Shift, and I'm going to select the 4 of these. And then I'm going to go over to Tools, and I'm going to go Join. Oh, wait, sorry. Last object you want to select, my bad, is that cube in the center. And make sure you select it. Oops, I selected the camera. Ah, watch out for that stupid camera. The camera is actually, because this software will actually allow you to do many things. You create games, movies. It's great software once you get to know it. So I cut the camera out of the way. I'm going to select the motor supports first, and then select the cube in the center. And now what you'll do is you'll notice that that puts our location to 0, where if it wasn't the last thing I selected, say that was 34 by 34 is what our total is going to be. So I'm going to select that center, go back over to Tools, and I'm going to press Join. These are now one object. They're not manifold as in that they're not all connected to each other yet, but they are all one object. I'm going to press Tab, A to unselect everything, hold my mouse over top of an object, and press L. L will select everything that is attached to that. I'm going to press Delete, select Vertices. Now my objects are still centered as 0 as one item. Go back over here, I'm going to go Boolean, Union, select, apply, delete the original, Boolean, Union, apply, delete the original, delete the original, and delete the original. Okay, so now these are all connected to each other. I want to connect the ducts, so we're going to go Boolean, union, duct 1, apply, delete the original, Boolean, union, apply, delete the original, okay. Oops, I accidentally, press escape, get you out of whatever you're in, make sure everything is still 0, 0, 0, 0, which it is, but now this is all one object. So I can move it all around. It is one solid object. Now to test this, because whenever you print something, I'm sure you've probably downloaded things from Thingiverse and they've come up and they've said that they're not manifold. And basically manifold means that the object is solid and that there are no holes or overlaps or things inside of the object that, let's say if you were to fill the inside of the object up with water, that it wouldn't spring a leak somewhere. So to do that, there is actually a feature inside of here to test for manifold. So I'm going to press Tab. I'm going to press A to deselect everything. And then I'm going to go to Select Non-Manifold. Now, if anything in here wasn't manifold, so let's say I deleted this vertex. Now, you see I've got a hole in the object. And I mean, this can happen in many other ways, like many of ways. When you're joining objects or something like that, if something didn't line up or the program had a conflict with something, it'll actually turn around and leave a hole somewhere. It won't really happen to you until you start getting into complicated objects, but so if we go select non-manifold, you'll see that it actually says, oh, there's a hole and this is where it is. Now, I don't want to actually do the math of figuring out where that point really should have been, so I'm going to press Control Z until it reappears. Press A to make sure I deselect everything and go back to non-manifold. And it shows that it's manifold. Another good feature is if I press A to select everything, I can go over here and click Remove Doubles, and this will just remove double overlapping parts. Now the reason why I've actually made it so that when I assembled this, that these extend down here, and that's to prevent overlapping vertices. So that's pretty much what it is. That's where we're set to, and that's our basic frame. So what I want to do now is I want to actually cut this thing flat so that it adheres flat to your actual print bed. So to do that, I'm going to take whatever object is actually extruding out the bottom the most, and that's these. So I'm going to select those, and only those. I'm going to just drag them way down. There we go. Done. Then I'm going to select the next parts. And you hold Shift, of course, to select multiple objects. Back off, grab a hold of the Z, and drag it on down. So this is making a really tall object, but that's okay. Next part. Now, this program can be a little quirky. You won't really understand why it's quirky. Like, it's not really quirky, but it doesn't do some thinking for you. Now, mind you, it does a lot more thinking than most CAD programs. But you'll find out that when you do certain things a certain way, that you might get an end result that isn't exactly what you expected. So you'll learn that as you use the program more to do things in a certain manner. And that's why, once again, I left these objects kind of hanging down so that there weren't vertices that were too close to each other. So I've made sure I've selected all those faces, grab Z, and drag it down. Okay, so what I want to do here is I want these motor supports. That's what I'm going to actually use as mine. So I'm going to go Tab, Vertice, and this is basically where the top of the motor is going to sit. So 10.5, I want to have the motor encased inside of 5 millimeters of space. So 5.5 is basically where I want my bottom surface to be. So I'm going to create a cube. Make sure once again you're not in tab. Let's create a cube. I'm going to center the cube. I'm going to drag it way below the object. I'm going to select my print bed surface. And what this does is this allows me to confirm that the object's going to print on the print bed. If you want, you can do a 45 to see if, So this actually just allows you to quickly confirm that everything's going to sit there. I'm going to go back to 0. Make sure I drop it down well below the object. Go into tab mode. Select the upper face. And I'm going to put that face to 5.5. There. You notice it consumes quite a bit of the object. So now I select the object, Boolean, difference, and select the cube, apply, and we can delete this cube now. Now, this object is perfectly flat in the best way. There's no stray vertices, there's no nothing. We now have the basic frame. Okay, so now I do see a weak point, and that's actually going to be right here. So what I want to do is I'm going to press tab, I'm going to select that face, and I want to elevate that up just a little bit. Remember, you don't want to overlap any other edges, because if you do that, you'll see you kind of get like these shadows, and that means that there's actually a fold along a face, and that will affect your printer later on. So I'm going to bring that up, and let's say 13 got me the closest, but to a solid number. So that was good. Select my next one. Let's take Z to 13. Okay, so now I've added that for strength, but there's a lot of extra surface that you don't really need. What really adds the strength is the distance. So fiberglass guys will actually understand this. Anybody that does fiberglassing or carbon fiber, anything with resin, understands that the reason why there's more than one layer isn't to add structural strength in the fact that 2 is better than 1. It actually allows space for resin to sit in between the 2 layers, allowing the 2 layers to be spaced apart from each other. And that's what actually creates a very stiff, strong form. So the fact that we have surface all the way from the top to the bottom is rather unnecessary. So what I'm going to do is I'm going to select this face, and what that's going to do is it's going to give me a Z center. And that Z center is 9.25. So I'm now going to create a cylinder. I'm going to center that cylinder. Now this cylinder is up and down, so I want it to rotate 90 on the X there. I want to set the height to center of those 2 faces. Set the length to, let's say, 200, something that you know is going to clear. And now I'm going to mess with the diameter. So let's go 6 by 6. It's a little bit too thin for what I'm comfortable for, so I'm going to do, let's leave 6 on that and go 5 on that. So that's not too bad. And you know it's going to be center. It looks pretty good. So I'm going to select. Actually, you know what? I'm not going to do this yet. We're going to add a surface in the middle to actually support your flight controller, camera, things like that. So I'm going to delete this. Just for now. I'll come back to that later. Okay, so we've got our ducts, we've got our center, but we're going to need a place to actually mount our FC and everything. So to do that, let's create, let's say, a cube. So we've got a cube. We're going to put that cube in the center. Good. We're going to set our cube at, let's go 40 by 40. That's a good bit of surface. 40 millimeters by 40 millimeters. That's probably a bit too much. Let's go 30 by 30. that looks good. Now we don't want these little points extruding out past the edge. So what I'm going to do is I'm going to make sure it's well inside of that of those faces. I'm going to go Boolean difference. I'm going to actually just cut out the object with itself. Done. Okay. So now, if I was to isolate this object, you'll notice I have 4 points that are unattached. So we're going to press Tab, A to deselect everything, hold my mouse over a face and press L. L is going to select everything that's attached to the face that I'm pointing it at, or the vertice or the edge, and I'm going to delete those vertices. There we go. So that's our object. So now the big thing is though is we're going to end up with unattached points. And that's because this is actually just on the outside of this edge. For these to properly join to each other, I want them to be inside the other edge. So what I'm going to do is I'm going to press Tab, make sure I'm on face. I'm going to select these two, and I'm going to press Extrude 0.1. No, let's go 0.3. There we go. Good. Move on over. Boom, boom. Extrude 0.3. So you'll notice that they actually extrude now inside. 1, 2, extrude 0.3. And extrude 0.3. Okay. Out of select, lift it up, make sure it's well inside, and go Boolean union plate apply. There we go. Let's delete the original. That's pretty good. Tab. I'm going to do what I did last time, actually. So let's go select the faces. Remember, these were cut to 5.5, so that's what we're going to do again anyway. Done. So I've now selected all of the lower faces. I'm going to drag them up. Create a cube. 0, 0, negative 50. There we go. 200 by 200. Oop. 200. Tab. Select the upper face. 5.5. Make sure that our face is above that one, which it is. Okay. So now we go Boolean difference. Select. Apply. And we get rid of this cube. So now, the center of my mouse is actually starting to die. I've used this program so much. Now we have no overlapping vertices. We have nothing. It's a perfectly cut lower base. You'll notice that every once in a while they'll produce an extra line here and there. And that's just to basically maintain what is the internal face and what isn't. That's why they'll put little lines here and there, little edges. Don't worry about that. You'll actually find that you'll produce some of your own. So if you go to, let's say, Tools, Knife, you can select 2 points. That'll isolate that. Isolate that. So, I mean, you'll get more into that later, and I'll put up more tutorials more in depth. I just wanted to give you guys kind of a long starting tutorial here to kind of get you going to everything that you really need to know, and then I'll add pointers later on as, let's say, people ask. So we know our bottom surface is 5.5. Let's say we want to make this plate 1 millimeter thick, so we're going to make that 6.5. And that's pretty good. So the whole height of our object is 11 millimeters tall. So, I mean, that's not too bad. That's pretty good. Okay, so you'll put your flight control and everything on the top. Your motors are going to actually extrude out the bottom. But you need a place to put your battery and your camera. So to do that, first of all, we're going to need to know what your camera dimensions are. So I'm going to open up another program with, let's say, my camera dimensions, which is this one. So I actually went a little bit more when I did this model. Well, first of all, I cut out more spaces like this, which was just basically I created cylinders, laid them on 45-degree angles, and cut out to make these notches. You already know how I made these holes. These are where the nylon standoffs actually go, as it's built in layers. And because for mine, I have a flight controller plate, which if we go out of this view, we can go down. So this is actually the battery and flight controller plate. I'm going to move that up to my other model. And if you look in the center, this is the actual dimensions of my flight controller. So to make that all work, what I did is I actually added these little points here so that they cover the flight controller so that there's nothing in the way. Airflow is being kind of directed around the flight controller. And that all just fits up inside when you bolt it all together. You'll see there's your clearances. And it's pretty tight. But this thing has proven to be extremely strong. And I like doing it this way. Now, you'll see originally my design had these posts here, here, here. I mean, there's actually many different designs in this program, including this one, which is a solid print where the battery actually, see the elastic band, oops, slid over top of the battery holder and sat in between here, and then you press the battery into the holder here, and the camera was moved forward so that the weight distribution was properly distributed. Flight controller went below the camera, and that was it. And this was my original design. So you'll see that I just, go model after model after model until you keep modifying and creating and whatever. So the parts I want are, let's say, the camera. I know there's a camera in here somewhere. Camera cutter, where are you? Oh, there it is. So this is actually a model of my camera, so I'm going to copy that. I'm going to cheat here just for the saving of time, because I think you can probably figure out how I made it. That's my actual camera holder. That's the flight controller. So I'm going to copy those, and let's head back over to the other program, and I'm going to paste them. Drag them all kind of in the center. There we go. So now you'll notice that the flight controller here is pretty tight. It's going to be pretty tough to fit that in there. Okay, so you're going to notice that at this point, I'm using a slightly larger flight controller on mine anyway. I'm using the Eachine 6-motor FC with my unit. So what we want to do here is we're going to need to make a little bit more space for the actual flight controller to fit in here. Now on mine, I did quite a bit, but I'm not going to get you guys into something that complicated quite yet. So we know that this is the flight controller. So we're going to basically, we see that these are the points that we're going to get stuck at. Okay, do you know what? Originally, because my design was quite a bit more complicated, for here, we're going to make up our space differently. So I'm going to, first of all, our object is centered, so I'm going to press Tab. I'm going to press A to select everything. 7 to give us the top view, and I'm going to isolate. There we go. So everything's isolated. Oops. I want to actually grab the flight controller as well. Done. Okay, I'm going to isolate those two objects, press 7 to get our overhead view. So reselect, press, oops, sorry, excuse me, press Tab. So now we need to make a bit of space. Now, unfortunately, in surface view, you can only select vertices, faces, edges that are visible to you. What I want to do is actually select below that. So I'm going to press Z to go into wireframe mode. Press A to unselect everything. And now if you hold Control, you can actually drag a line. And because we're in wireframe mode, you're going to get every layer of those vertices. So I'm going to collect, drag, make sure I get them all. And I want to add a little bit more to the Y. So let's start off with 3 millimeters. 36.2587. Now you notice that it might be off a little bit, and that had to do, once again, this is collective surface. Well, right now I'm in vertices, so this is collective vertices, and some of those vertices will be a little bit off because there's these oddball lines that kind of split various surfaces. But I've added 3 equally to both sides. Let's get out of edit mode and out of Z mode and take a look and see if that's okay. It fits, but you know what? Maybe we can use just a tiny bit more space. So let's go and do that again. 7 to select, Z to go back into wireframe mode, and Tab to go into edit mode, A to unselect everything. And we want to keep this all in an X configuration. Now remember, we've got ducts that are in the way. I mean, depending on if you build yours with or without ducts, then you're not going to have the same problem that we're having right now. With mine, I layered it, which actually lowered the flight controller and everything. So I'm going to go to 6. Well, I got too close there. Let's try that again. There, and 6. Alright, Z, Tab. Now we have plenty of room. Okay, so that was a quick and easy way of fixing that problem. Let's get back out of the edit mode. Let's grab our camera, bring our camera down. Okay, so this is the camera mount for the Eachine. I don't know. It's a metal case. Oh wait, I have it. Eachine EF01. Inexpensive camera. Comes with a metal case. You can remove the metal case to actually save yourself about 3.5 grams. Honestly, with the metal case in place, it prevents from the separation of the boards that I get with some of the other cameras when you crash on top of the antenna. I know some people like to mount the antenna pointing down or out the back to get it out of the way. In that situation, you're fine. For me, honestly, I build this thing so that I don't have to worry about it. I can practice. I can try things that I normally wouldn't try with like a bigger drone or whatever. I want to practice with this thing and fly it, and you know, I want to crash it, and I want this thing to stand up. So I'm going to leave it in the metal case, and that's what this actual camera holder's for. So now what this camera is I've made the dimensional box of the steel camera. It's a bit longer than you would expect it to be, but once again, it's for cutting purposes. And I made the holder to hold it. And then I wanted the camera on a 15-degree angle, so negative, so tilt it back 15 degrees, and that's my camera angle. So we don't really need the camera here, so we'll take that out. So because I'm using a pre-built part, and you can do this, you can download parts from Thingiverse and use them too. So I'm going to go Tab. I need to know what these holes are. Now I know the holes, I believe, are 17, but I'm going to select, there we go, 16.98, and that just simply has to do with there's a couple extra lines in here. So let's say 17, well, yeah, that's fine. Alright, so I'm going to, now I'm using 3mm screws. Once again, when you print, your holes are going to be a little bit bigger, so what I like to do is I like to make the screw holes 3.5mm. So I'm going to create a cylinder, and I go 3.5 by 50, it doesn't matter. I'm going to put that at a 17, 0, and 0 with a model. Okay, so there's one screw, copy, paste, negative 17 for the other side. Okay, so the standoffs are actually going to go there, and the camera's going to go on the top. I like standoffs because it allows you to use different size standoffs to select different camera heights. Okay, so dilemma here is that the object just isn't wide enough to support the camera. We can solve that. So I'm going to go Tab. I'm going to isolate the object, first of all, just so I can produce the cuts. So I'm going to knife the project, so select knife. Now, you can select anywhere along the edge, but let's say you want to select like the center of the edge. You can hold down Control, and it'll actually snap to either a vertice, an edge, or the center of an edge. Well, sorry, the vertice or center of edge. And there we go. 18's on the edge. We're pretty close to 0. There might be a little bit of deviance. To fix that, you can basically re-zero it. You should notice that it didn't even move, not at that many decimal points. So that's that. I'm going to cut it in half again. Cut this side in half. Remember, I'm holding control to select the middle. So that's not bad. So that's that. Flip it on over, do the same on the other side. My poor desk. I need to use a mouse pad. That's what's happening, is it's basically getting lost on my desk. My shiny desk. Okay, now I'm going to go out of the isolation mode, select the faces, and I'm going to extrude, let's say, 3. Now, I can scale, nope, I want Y. Let's go 0.7. There we go. Extruded 3, scaled on Y, 0.7. Same thing here. Extrude 3, enter, scale, Y, 0.7. Okay. Exit out of edit mode. Boolean difference. Side 1, apply. And Boolean difference. Side 2, apply. Okay, so now what you can do is you can mount your flight controller and your receiver on top, insert your standoffs, take a rubber band, hook it on the outside of the standoff, underneath, back over to the other standoff, lower your camera over top, screw your camera down to the top of the standoff, and now you have a drone that lands on the motors and has your flight controller, your receiver, everything in it. So that's this part. Now, what I like to do with the plastic models instead of using rubber is I use this tube of stuff that you can buy at Canadian Tire, and it's called Amazing Goop. I usually buy the automotive stuff, and it's a silicone-based adhesive. It's an adhesive sealant. Now, the great thing about it is this stuff will stick to metal, stick to plastic. It won't corrode or melt your plastic or eat your plastic or whatever you attach to it. It'll stick it together, but if you really need to pull the motor out, you can work the motor out. The glue, the silicone will let go as you're pulling the motor out. So you can glue your motors into your positions and hold them down. The last step, though, is because we are landing on the feet of our motors. That's going to cause some harm to the wires. So let's make some quick little wire savers. So I'm going to go back. I'm going to find those motors. Actually, you know what? We don't even need to find the motors. Let's create a cylinder. Now I'm just going to glue these little feet onto the bottoms of the motors anyway. So I've got a cylinder. I'm going to isolate the cylinder. I'm going to make the cylinder, we did the last one 8.7. Let's do 8.8. 8.8 by 8.8 by, I don't know, 10 tall. Create another cylinder. These are going to be glued directly, so there's not really going to be any stress. So we're going to go 8.8, 9.8, 10 is 1.2. So we're going to go 10 by 10. I'm going to make that 10 tall. Now, because they're both 10 tall, that's 10 tall, that's 10 tall. If you want the lower part to be, let's say, 0.5 millimeter, then all you have to do is set them both to the same. So let's go 75. And you can do this one 74.5. There, they're offset by 5. This cylinder is just cylinder on its own. So we go Boolean difference. Oh, see? Cylinder, apply, delete. So this is 10 millimeters tall. I mean, that's rather huge. We only really need to be like 3 millimeters tall. So tab, select the bottom. The bottom is 69 point, that's 70 millimeters. So this will be 74 millimeters. Okay, so new dilemma that I forgot to think about. Wires. We need to have space for wires. So what I'm going to do is I'm just going to create a little wire cavity. So 1, 2, 3. Actually, let's go 7. So we want to select A. I'm going to select the object, so 7. Come on, center. Okay. Let's select U, and U. U, and U. Going to drag them out just a bit. This way the wires can come up the sides. Tools, knife. I'm just separating these pieces so that basically they know where their internals are. You'll find out from time to time that when you create an object that you'll see like a shadow or a piece of face that's kind of shifting off to the one side. Simply adding a couple of knife marks will simply fix that. Especially when you're extruding outside of an ordinary object. Alright, so that'll give room for the wire to come up the sides, and literally what I'll do is I'll put a little dab of automotive goop in the bottom of this cup, stick it on the bottom of the motor, and now whenever I land on the bottoms of the motors, the wires are protected. This little guy will weigh almost nothing. Let's say, I don't know, let's say you want to shave a bit more weight. We can go create cylinder, 7x7. Boolean difference. There. Now you would just glue it around the outside. Wires may still extrude out the bottom, but I mean, at least you won't be landing between the wires and the motor base. This will produce a bit of space. Honestly, I prefer it to be pretty general, or what you can do is make this only like, I don't know, 3 millimeters by 3 millimeters. 4 by 4. Boolean difference. That's better. Shave a tiny bit of weight. Literally that weight is unnoticeable anyway, but I mean, peace of mind. That'll also allow the glue to kind of squish out the bottom and you can wipe it off with your finger. Alright, so let's put that at 34 by 34. Drop it down. Okay, so we've created our model. This will fly. This will allow you to insert the 4 motors, but now you need to actually get this to the printer. That's the easy part. Aside from saving it, so you can go File, Save As. You can say I save often, which I recommend. If you're creating a project, save often. You'll never know what step you screwed up at. This way you can go back prior to that step, open the project, copy the objects that you wanted, or the object in the state that you wanted, go back to the recent project and paste them in, and you can recover things when you really F up. But to actually make this, we're going to go File. So you want to make sure just the one object is selected. File, Export, STL. That's it. So I'm going to do one last check for... Now remember, when you check for Manifold, you have to be in Vertice mode. Select non-manifold. Nothing lit up. You can press the period to confirm that. Nothing lit up. I'm happy. File, Export, STL. Save it somewhere. Open it up in your printer and print. So now, when you're printing an object like this, it's going to probably warp on the bed. So when you print it, you're going to want to print it with a kind of a brim around the outside of the object so that it adds more surface area to hold down these thin surfaces to the actual print bed. But with most slicers, they only add brim around the outside of the object, which means that there's not going to be any brim on the inside here or on the inside of here. So these will actually curl up. Now there's a really easy fix for that. Usually your first layer, I print my first layer at about 0.4 millimeters. It's pretty thick, but it allows it to be more squishy and adhere better. So what I want to do is I want to actually make it so that this surface can come on the inside. To do that, I'm going to create a cylinder. I'm going to make it 1 by 1 and make it, I don't know, 20 mil long. I'm going to put it on its side and I'm going to rotate it on 45-degree angle. I'm going to find out what the base of this is, which I believe was 5.5. So 5.5. I'm going to line this up at 5.5, and I'm going to set it to, I don't know, let's try 60 by 60. Nope. Negative 60 by 60. There we go. Now you'll notice that it just kind of slices just through the edge. Now because this is 1 millimeter thick, it slices through 0.5 millimeters, which means the first layer, and then if you do like a 0.1 layer, so the first layer and the second layer will be detected as lower surface. So I go Boolean, difference, select, apply, and then over here we're going to go 60 and negative 60. Oops. And if I press period, now it's on the opposite side, Boolean, difference, select, apply. Now I'm going to do both positive, 60, 60. And if I go to it, now you'll notice it's on the wrong angle, so I'm going to go negative 45. Boolean, difference, select, apply, and negative 60, negative 60. And I don't need this anymore. Okay, so what this is going to do is when it goes to print, it's going to see this is outside, 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 in here, outside, 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 outside. Right? And that will allow the brim to actually be brim on the outside, brim on the inside, and brim on the outside of here. If you were concerned that there might be an issue here, what you could have done is made this brim, let's say, 50 long and negative 50 by negative 50. And what that would do is that'll do a brim on the inside, a brim on the inside, brim, 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 out, and brim, right? You don't really lose much. You basically lose that first layer. By the time it adds the material in, though, for the brim, it's going to fill up that space anyway. So this is just for basically forcing the printer or telling the slicer to add brim on the insides of the objects. For me, I find that just brim, 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 brim right around here is fine enough, and my printer with its nice heating bed and all this other stuff, and I use blue tape, prints just fine. So that's your that's kind of your first 3D model micro drone print. If you want to actually figure out what your center-to-center motor is, we can do this. So remember, these motors do exist. So we got motor 1, visible, 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 visible. Oh, we added 3. So this will be 37 by negative 37. This will be 37 by 37. Negative 37. Negative 37. Negative 37 and 37. Okay. So that recenters our motors. So I'm going to create a cube. I'm going to center this cube I'm going to drop that cube down so that it's in a visible place. Go 1, 2, 3, 4, and cube. Now you'll see cube is the yellow one, so when I go to tools and I click join, it's going to use the cube's location to actually join all the objects to. Now if I rotate these on a 45-degree angle, I get my X and Y, press tab which puts you into edit mode, select a face, select a face. This is 52.3, so that's the radius sort of, or half width. So the actual wingspan of this is 104.658, I guess. But yeah, so it's basically it's a 100 millimeter model, or I guess a 104 millimeter model. Not bad, not too huge. It's a little bit bigger than a 90, but yeah, easily made on your 3D printer. All the parts fit nice and easily, and you know that your blades are going to be well protected. Okay, I hope you enjoyed the tutorial. Sorry that it ended up taking so long. It's kind of hard to squeeze all this into one, but just a quick recap. N gives you this side chart right here, which allows you to rotate, place, and set your dimensions. S is to scale. You can either manually scale with the mouse, scale along Z, scale along X, scale along Y, or Shift Z, Shift X, Shift Y. And if you're in the middle of a process and you want to get out of it, Escape, Extrude, so if you're inside an object you want to extrude, you do a manual extrude, you can extrude X, extrude Y. Now because you're doing a single surface extrude, you'll notice that it kind of keeps the surfaces tight. You don't really want to do that. Extrude Z. Negative extrude does have its purpose. So if you were to, let's say, not extrude, but scale to 0.5, and then extrude negatively, oops, I went too far, extrude negative, you can produce objects like that. Z gives you wireframe. Tab gives you the ability to edit an object either through vertice, edge, or face. And the slash over the number pad allows you to isolate selected objects. You can isolate one or multiple selected objects. This little wrench guy over here allows you to select from various tools. Whenever you're building 3D models, though, you'll find Boolean to be your big one, whether you're joining, cutting, or intersect. Now, the great thing about intersect is, let's say you want a square with round corners. So I'm going to create a cube. I'm going to isolate that cube. I'm going to put that cube to 20 by 20. I'm going to center it, period to select the center. I'm going to create a cylinder. The cylinder is going to be, let's go 20 by 20. We're going to zero it out and give it a 10. Now we want rounded corners, so let's do 24 by 24. If I select an object and I go Boolean intersect, it'll actually only allow the object that existed inside of the object that I selected to exist. Press apply. I can delete the object that I used, and now I have a cube with, or a square with rounded corners. So play around with it. Ask me questions or anything like that, and I'll put up more tutorials kind of to cover specifics as we go. Okay, have a good one.